In this video we present an immersive system for stereoscopic dome-shaped light field capturing and rendering, which was built for European Space Agency's project called Light Station, Mobile Light Field Station for Remote Geological Sampling and Imaging. The Light Station is a direct continuation of a previous Light Space project. The system includes the following functionalities. Data capture. Camera positions are calculated to uniformly cover the capture volume and produce the shortest path trajectory. A programmable motorized rig with Canon camera and a dual fish-eye lens for capturing the light field data. Data processing. A simple Python scripts for batch image processing, splitting, resizing, cropping, and masking. Light field authoring. Unity editor project for light field generation and asset bundle exporting. Light field rendering. Unity engine components and compute ray tracing shaders for stereoscopic dome-shaped light field rendering. The capture rig is built around an acrylic dome 0.7 meters in diameter. The dome can rotate 360 degrees, while the camera moves on an arc of 75 degrees. The camera is fixed in the camera cradle and moves along the camera rails using 3D printed rollers and a round gear rack attached to the dome surface. The camera cradle holds the camera body, stepper motor with a driver board, and a hybrid 1:135 ratio gearbox. This large reduction ratio gearbox is suitable for moving a heavy camera, locking it in place without spending stepper motor energy, and maintaining sufficient movement speed. The single 6000 mAh battery powers camera, 2 stepper motors, and a wireless board. The camera shutter is controlled through servo output of the master driver board and is synchronized with the motor's movement. The master stepper motor with a 1:25 reduction ratio gearbox is used for 360-degree dome rotation. The stepper motor is controlled by a master driver board with wireless module attached. The wireless module creates an access point, contains web server for hosting a user interface page, and has a file system for job recordings. The job recording contains a list of G-code commands which specify dome and camera cradle rotation for each camera position. During the data processing stage, each image has to be split into left and right parts. The images are cropped to reduce field of view by 5%. Left and right images are then swapped to match the correct eye. During the early stage of light field authoring process, the capture volume size and shape, along with camera movement limits, are specified. Then, camera positions and trajectory are calculated. Camera positions are based on spherical triangulation with regular icosahedron subdivisions. Regular icosahedron perfectly approximates spherical surface with 12 vertices, forming level 0 light field dataset. By subdividing edges and reprojecting new vertices onto the spherical surface, it is possible to produce new approximations, levels 1 to 5. Each new approximation contains more camera positions, 42, 162, 642, 2562, 10,242. Since camera movement has its limits and the dome is a half sphere, some of the camera positions will be unreachable, bringing total position count to 976 for level 4 dataset. Camera trajectory is calculated as shortest path between reachable camera positions, starting from the top. After that, G-code commands to reach each camera position are calculated and exported as job recording file to be uploaded to the capture rig via web interface. After the dataset is captured, the virtual cameras and a proxy geometry rig are created during the final stage of the light field authoring process. It mimics the real camera positions, bringing the real-world imagery back into the virtual environment. Photos taken during the capture process are converted to textures and applied to proxy geometry objects. The textures and camera positions are then transferred to the compute shader as parameters. The light field rendering process is done with a ray tracing compute shader. Ray tracing is used with primitive objects, planes, quads, disks, spheres, half-spheres. The mesh ray intersection has high computational cost, so using spherical primitives with a VR180 camera enables real-time rendering and is crucial for this method. Compute shader uses parallel computing on GPU and render kernels. The acceleration structure, bounding volume hierarchy, is implemented to speed up the rendering process. Disk blending method is used to generate new perspective views from existing ones, where each blending disk serves as a window to its own half-sphere proxy object with a texture from real-world photo applied. Rays are emitted from virtual camera position and intersections with a multiple, up to 8, overlapping blending disks are calculated. Rays continue to go forward until they hit proxy half-sphere object for each disk in order to obtain color information from their textures. The ray's color value is then computed as weighted average between all overlapping disks hit by this ray. The light field has the same shape as its capture volume. The light fields can be rendered in multiple ways, directly to screen for VR applications, to Unity's render texture for blending with traditionally rendered objects, to 180 degrees fisheye texture, or to 360 degrees equirectangular texture in case of the panoramic light fields. Light fields can be refocused by changing the proxy object scale. That is the core property of the light fields, along with the ability to show dynamic reflections and shadows. Stereoscopic light field of level 4 contains 976 photos and takes 117 minutes to capture. This light field in 4K resolution requires 24 GB of video memory and up to 96 GB of system memory. The asset bundle compression ratio for level 4 dataset light field is 8:1, from 20 to 2.5 GB. The level 5 dataset was not feasible in this project, since the 5th icosahedron subdivision produces 3,866 reachable camera positions. However, it is possible to capture the dataset of this size by filming a video instead of taking individual pictures. By rendering this dataset in 2K resolution, the memory requirements will remain the same as for level 4 dataset in 4K.